Blazor WebAssembly is turning the web development world upside down. With Blazor, you can keep coding every part of your web application, meaning front-end and back-end, with the programming language and the framework you love, C# and .NET. No need for JavaScript anymore, and you can even use the same classes and methods you write for the server as well as for the client. We will dive right into the code by first having a look at the standard example project of Blazor WebAssembly, and then we already built the main project of this course, which is a classic online browser game where users can create an army of fighters and send them into battle against other users. With some customization options and climbing the leaderboard, this application will teach you how to use Blazor WebAssembly with Razor components in a playful way. We will have a look at data and event binding, communication between components, forms with their built-in components and validation options, how to use views only authorized users can see, how to make calls to a web service, and much more. Additionally, you will learn how to build the backend of the browser game with a web API and entity framework to store all the data in a SQLite database. So by the end of this course, you will have what it takes to call yourself a full-stack Blazor web developer. With your new skills, you are ready to conquer any upcoming .NET web development project you want to build yourself or any project that is requested by a recruiter. The only tools you need are Visual Studio, Postman, SQLite, and a browser like Chrome or Firefox. Everything is available for free and also cross-platform, so you can follow this course on Windows and Mac OS. My name is Patrick and I will be your instructor in this course. I'm a web developer for over a decade now. I have worked for big corporations and small teams, as an employee and a contractor, and I just love to see the way Microsoft is going with .NET and Blazor and how important these technologies get day by day. To this date, I was able to run 7 courses on web development on Udemy about .NET Core, single-page applications, Angular and DevOps, with a total of over 50,000 unique students and more than 5,000 reviews. So you could say my courses are booked by a full Aloha Stadium in Hawaii. Are you ready to make the next step in web development? I'm looking forward to seeing you in this course. Welcome and thank you very much for joining the Blazor WebAssembly Full Stack Bootcamp. After the next couple of hours, you will have what it takes to build a modern web application from start to finish with Blazor WebAssembly, Web API, and Entity Framework, so that you can really call yourself a full-stack Blazor and .NET developer. We will start with the client application, where we utilize Blazor WebAssembly. You will learn how data and event binding works with Blazor, what Razor components are, and how they communicate. There are several ways of communication between components like parameters, events, and services, and you will see how to implement them all. Additionally, we will build forms with all the controls Blazor WebAssembly provides, like input text fields, checkboxes, select fields, and so on, and we will also see how validation in these forms work. Authentication is also very important, of course, so we will implement a custom authentication state provider and use the authorized view component to control access of authorized and unauthorized users. Don't worry, you will learn what all these things are along the way in this course. To authorize a user, we will use JSON Web Tokens and actually create that token later with a web service. We will call this service using an instance of the HTTP client class. As already mentioned, we will also build the backend of this application with a web API and entity framework. The web API provides all the controllers. These are the web service in essence, which is called from the Blazor WebAssembly client application. Entity Framework is used to create a SQLite database with all the necessary tables using code-first migration, so all your data will be stored persistently. But the backend will be covered later in this course. We will focus on the client first. So let's move on with some preparations and then start building the application. The only tools you need in the beginning are the .NET SDK and Visual Studio. Depending on when you're watching this course, you can choose to download the .NET Core 3.1 SDK, the preview of .NET 5, which will combine .NET Core with the older .NET framework, or .NET 5 has already been released, then you're safe to choose this SDK. This course will use .NET Core 3.1 because by the time of recording these lectures, this version has been the latest stable release. So to be absolutely safe, please choose this version as well. Regarding Visual Studio, you can use the Community Edition of Visual Studio 2019. It's totally free and provides all the functions we need. If you decide to use a preview version of a .NET SDK, you probably also need a preview of Visual Studio. Just keep that in mind. Otherwise, the latest released version of Visual Studio is perfect. If you already want to get the necessary tools for the backend, you can download and install Postman, which we will use to test our web service calls later on. Sometimes it's just nice to test a call to the web API before you build the corresponding frontend. Additionally, you could already download the DB browser for SQLite, which enables you to, browse through a SQLite database. But again, these tools are used later in this course. For now, please download and install the .NET SDK of your choice and Visual Studio 2019 Community Edition. One last thing before we start with creating our Blazor WebAssembly project. You can get the complete code you will see during this course on GitHub. Here's the link to the repository. As you can see, the commits in this repository match the structure of this course. So if you're struggling with your code, please have a look at this repository. I hope it helps to find a solution. Or just grab the code and build your own browser game with it, whatever you like. Anyways, if you still have any problems with the code, you can also reach out to me, of course. Now, let's create the project. Alright, when you start Visual Studio, choose Create a New Project first. And now we see a bunch of templates here, and we want to create a Blazor application. So we are selecting Blazor app, and if you don't see it here in the templates, we can always just search for this. And don't worry, later or in a second, we will choose if you want to create a Blazor WebAssembly or a Blazor server app. So first just select Blazor app, and then we give this thing a name. For instance, Blazor Battles, because this will be a game where we can fight some battles. Okay, the location is up to you, of course. Solution name will also be Blazor Battles in this case. And then we click Create. Okay, and now it's getting interesting. We have a bunch of options available here. First, the .NET SDK version. As already mentioned, I'd like to use the .NET Core 3.1 SDK. And then we can choose between a Blazor server app and a Blazor WebAssembly app. Well, according to the title of this course, we should choose Blazor WebAssembly here. If you don't know the difference, just real quick, a Blazor server app runs completely on the server. There are no actual web service calls like you might be used to with a typical web application. And the description says that user interactions are handled over a Signal-R connection, meaning over WebSockets. So the user doesn't really download the client app to the browser, which is great, but the big disadvantage is that the server has to handle everything. So if your app has a lot of users, for instance, the server has to manage all the interactions of every user, all current states, and so on. And with a Blazor WebAssembly application, the server has a lot less to do because the client handles the interactions, which might be faster for the user, speaking of user experience and offline functionality, for instance. And this is the typical structure of a modern web application. Maybe you already built a web application with a .NET backend and a JavaScript framework like Angular, React, or Vue.js for the front end. And these frameworks handle user interactions as well and make web service calls to the backend. And with Blazor WebAssembly, it is the same thing in essence, but you don't have to write any JavaScript code. You can keep writing C# code and even use the same classes for the client and the server. I just love that fact. Okay, so long story short, we choose Blazor WebAssembly. Regarding authentication, we don't need authentication for now. We will implement authentication later by ourselves, which is a great way to learn. Now configure for HTTPS is fine, and then comes an important checkbox, which is ASP.NET Core hosted, and this we will select. With that selection, we will already get a server project and a shared project additionally to our client project. We'll have a look at these projects in the next lecture. For now, it's just important to know that this checkbox provides a solution where we can already make use of a web API, so a full stack web application in one solution with C# and .NET only. That's it. At the bottom right, you can double check the used .NET Core version and then click Create. And there's our new solution. Great. Now let's open the Solution Explorer on the right, and then you see what has been created for us. The shared and the server project, as already mentioned, and of course the client project. But let's have a look at the complete structure in the next lecture. So in the Solution Explorer of Visual Studio, you see 3 projects. We have the client project, server, and shared. Now the client project represents the front end. Here's where all the Blazor WebAssembly magic will happen. The server project will be the home of the web API and entity framework, and the shared project will be used to share classes between the client and server projects. This means building a model once and using it for both the client and the server. You can already see the weather forecast model here, for instance, but we'll talk about the example application in the next lecture. Let's have a look at the client project first. The program CS. This file with the main method here is the starting point. We will mainly use this method to register new services we write by ourselves or services that will be added by new packages. You can already see that something is happening here with the HTTP client class, and above you see that root component is added, which would be the app component we can find in the app razor file. This one right here. A component in Blazor is a razor file. That's why it's called a razor component. So the app component is the root component where you actually see the use of further components like the router here, the found and not found component, and the route view, and also the layout view here. Now, the router component that wraps the other ones in this case decides if a route that has been entered in the address bar of the browser is correct or not. If it is, the found component will be used to display the content of the entered route, and if not, the not found component will be used. Both components in turn use further components, a route view and a layout view. And these two make use of the main layout. But let's stick to the layout view first. It uses the main layout, but the content can already be seen here. It's simple text wrapped by a standard HTML paragraph tag. The route view, though, uses the main layout, but with the content of the actual page the user wants to see by entering a particular route. And this page can be found in the Pages folder. This one here. But we'll get to that in a second. Let's have a quick look at the imports razor file. Now it's quite simple. You will find global using directives here. That's it. If you don't want to add a reference in a single component, add it here instead. Okay, next let's have a look at the main layout in the shared folder. Well, looks like standard HTML at first, right? Well, the only difference is that it inherits from the layout component base class on top right here. And when you look at this class, you can see that it has a property called body of the type render fragment, which is used in the main layouts with add body, and that's where the pages will be rendered. Additionally, you can see another use component, the nav menu right here, but we'll get to that soon. Now, do you already see how these things work together? A component can be used by adding a tag with its exact name, and any page will be rendered in the body part, this one here, of the layout. You could build a custom layout if you like and use that one instead of the main layout in the app raiser component. It's totally up to you. Anyways, let's have a look at the pages. For instance, the first one here, the index raiser. Now the crucial part is this page directive on top here with a string, which is already the route for that page. You don't have to specify that route anywhere else. Just create a component, add that add_page directive, and you're done. It's the same with the fetch data and counter pages. And we have a look. We see the fetch data right here. You see the add_page using directive with the string fetch data and counter as well. In essence, it's exactly the same. Now, before we have a deeper look at the code, a quick word about the other projects. The server project here consists of a program CS and a startup CS file. Now, in the startup class, we find the configure services and the configure method. The configure services configures the app's services. So a reusable component that provides app functionality. We will register services in the future in this method so they can be consumed in our web service via dependency injection, for instance, similar to the program CS of the client project. Now please don't mind all these buzzwords right now. Now the configure method creates the server app's request processing pipeline, meaning the method is used to specify how the app responds to HTTP requests. As you can see, we're using HTTP redirection, routing, and so on. With all these use extension methods, we're adding middleware components to the request pipeline. For instance, use HTTP redirection adds middleware for redirecting HTTP requests to HTTPS. Now the startup class is specified when the app's host is built, and you see that in the program CS file. This is done in the create host builder method. Here the startup class is specified by calling the use startup method. Now regarding the app settings JSON file, we only need to know that we can add and modify some configurations here. More interesting and often used throughout the backend part of this course is the controllers folder. The first controller you see here is the generated weather forecast controller, the demo controller of the standard example. We'll get to the details of controllers later. For now, it's only important to know that we can already call the get method down here, which is actually done by the fetch data component. And I'd say we do that next. Okay, let's run the application first and then talk about some files we haven't talked about yet. The great thing about Visual Studio and .NET Core hosted Blazor WebAssembly applications is that you can simply start this whole application with the little play button on top. Let's do exactly that. The actual starting project is the server project, and Visual Studio will fire up IIS Express with a browser of your choice to start the application. And there it already is, but let's have a close look again. Just reload this thing, and here you see the loading text. And now the question may arise, where does this come from? Well, we go back to Visual Studio for a second. And in the Solution Explorer, we see the client project has a folder www.root, which is, well, the root of the website. And next to some cascading styling sheets, we see the index.html file. And when we open this thing, here we see this loading text. Now, any resources you want to add later, like icons, images, other style sheets, and so on, they have to be added to this www.root folder. We will use this place later. The crazy thing now is that you can actually debug the client and the server at the same time. You see, back to the page, here on the counter page, that this button here increases the counter. Now let's have a look at the code. We go back, and then in the pages folder, we go to the counter component or the counter page. Now it seems like there's not much to see here, but actually that's already happening a lot. Now you already know the page directive here, and then you can use this current count variable, which can also be found down here in the add code block. This is the add code block, and here you see the variable current count. And with this add current count thing here, you already see how data binding is done in Blazor WebAssembly. So you can use this variable of the code block within your HTML code above. And in the button, this button here, you can already see event binding. The on-click event marked with the @ sign again calls the increment count method. Simple as that. And the increment count method, you know it already, increments the current count. By the way, if you don't like having your C# code together with your HTML in one file, you can create a code behind file for your C# code instead. But now let's set a breakpoint inside the increase count method. And now we go back to the page, and when we click this button here, we come to the client project and hit the breakpoint. Crazy, huh? And here we can see the current count. Let's remove the breakpoint again and continue the application. We see the result. And now really crazy is that this also works for the service project. So you start this application and you can debug the client and the server at the same time. So let's have a look at the fetch data page first. Back to Visual Studio, here the fetch data component, and down here in this method, this page makes a call to the web API of the server project. We can also see that in the network tab of Google Chrome. So let's just have a quick look. We open the console with F12, and now here in the network tab, let's make this a bit bigger and filter all the requests. Now in the fetch data, you see that here is a call to the web service, and we get this data here. You can see also on the page. Now looking at the code again, we can see a lot of new stuff. First, the using directives. We are referencing to the shared project here because we're using the weather forecast class. Then we inject the HTTP client, which enables us to make web service calls. Now inside the table, this table here that you have already seen on the page a second ago, there is a foreach loop. And this foreach loop uses the forecasts received from the service. We'll do all this later by ourselves, so please don't mind my pacing for now if it's a bit too fast. In the code block now, we see a new method called onInitialized async, and this thing is part of the component lifecycle, and it's called, as the name may imply, onInitialization of the component. And in this method, we are using the injected HTTP client to make a GET call to the weather forecast route, which would be the weather forecast controller of the server project, the one we have seen before, this one here. And this thing, by the way, you can see it down here, is using again the same weather forecast class of the shared project. So we see already that the client and the server project both use this single class here. Okay, now back to the controller. Let's make a breakpoint. Let's set a breakpoint here in the get method. Okay, and now let's see if we hit this breakpoint again by just reloading the page. And yes, there is something happening. The debugger is paused, and we can see that we actually hit this breakpoint. We can step through everything or just continue this stuff. Fantastic. Now, although being able to debug client and server at the same time is great, I like to run the application in another way actually. Because with the way I just showed you, you have to stop and run the project by yourself every single time you made some changes to your code. This slows down development. So instead, I like to use the Package Manager console with the .NET Watch Run command, which rebuilds the project when any code change has been recognized. There's only one problem. So far, this only works for the server project. If you make any changes to the client project, they won't be recognized, but of course we can fix that. Now first, how do you get to the Package Manager console? I have it open when I stop the application first. You can see that it is already open here in my IDE, but you can of course open it in another way. You can either choose the terminal or other windows and then the Package Manager console here. This is exactly the same thing. And the command I just told you is .NET Watch Run. But first, before we run this command, we make a little change. And to make that, we have to go to the project file of the server. Now you can see a bunch of item groups already, 2 of them, and we will add another one, item group, and then we add watch include, and then client, and then we want to watch any Razor component or Razor file of the client project. That's it already. Now what is happening here? With the .NET Watch command, the application is watching your code. So if any file changes, if you make any modifications to your code, the app restarts automatically. But this only works for the server project. But with this new item group here in the project file of the server project, we tell our application to also watch all the Razor files of the client project. So now if you make a change to the client project, the application restarts itself as well. Okay, now let's open the Package Manager console. And as you can see, we first have to navigate to another folder. This won't work here. You can see it when I start to run this application. It won't find any app here. So first we have to change the directory, go to Blazor Battles, and then also to the, as you can see here, we have 3 folders. So now we change the directory and move to the server folder. And now we can run the .NET Watch Run command. Okay, now when the app is running, you already see the URL we have to enter in Chrome. You see the localhost 5001 for HTTPS and port 5000 for HTTP. Now this URL can also be found in the launch settings JSON file. We have a look again. In the properties folder, we see the launch settings JSON, and down here you see the application URL. So now let's go back to Chrome and enter this URL. Now you might get this warning here because we're using an HTTPS URL and don't have a valid certificate for that, but that's not a problem. We just proceed to the URL. We see the loading again, and here is our application. Now, the breakpoints won't be hit, but we can make a change to the code and the app will recognize this by itself. So let's go to the counter page again. It's not open anymore, so we go to the counter page and say current count will be increased by 2. We save this. And now we can already see here it recognizes that a file has been changed and starts the application again. And now we can go back to the browser. And now just please note, when I now click me, it's the old version without the change. So we see 1, 2, and so on. And now we reload the page, we get the change, and now we see that the current counter is increased by 2. So this is the only thing you have to do. You have to reload the page by yourself, but I think this is This is okay. It's better than stopping and restarting the IDE or the application within the IDE every single time you make a small change. Okay, and now regarding the server project, we see that we get 5 weather forecasts here. So let's make a change in the fetch data or in the controller. So we are here at the server, and instead of 5 forecasts, we receive 7. We save this thing. Again, a change is recognized. The app is restarted. And when this is done, we can go back to Chrome again, reload, and now we're getting 7. You see, this makes developing your Blazor WebAssembly app a lot faster. One thing we haven't talked about yet is the nav menu. But by now you may already know how this component works. So let's have a look here at the nav menu razor file. Now you see some data and event binding here. For instance, the toggle nav menu is bound to the click event. You can see the method down here. And we have a binding to the nav menu CSS class property for the CSS class. So you can see that you can also bind to a CSS class. Or you can bind a CSS class, and this property only returns a string. So beautiful, this works the same way you have already seen it. New though is the nav link component, this thing right here. Now this is a built-in component for navigation links. The description already says it's a component that renders an anchor tag, automatically toggling its active class based on whether its href matches the current URI. And the href would be the string, this one here, that is used with the add page directives of your pages. So you see the counter string here, and here in the counter page, you see the string again. Now, one last thing I want to show you in this example application is the first way of communicating between components. When we switch to the index razor again, you see the use of the survey prompt component with a title. Now this title is actually a parameter. So the parent component, the index razor, can tell the child component, the survey prompt, anything with the help of parameters. Now when we have a look at the survey prompt component here in the shared folder, you see the title property in the code block. And it is marked by a parameter attribute. And then this title provided by the parent is used in the HTML above, right here between the strong tags. So that's how one way of communication works between a parent and a child component. Alright, now that should be everything regarding the example application. I guess this has already been a lot of input. Now let's make a new Git repository out of this and then start building our browser game with Blazor. Now to initialize a Git repository, we see on the bottom right of Visual Studio, add to source control. We click that and then we can choose Git. And that's it actually. Now we've got a local repository where we can commit our changes and have a history of them. We could also publish this repository to any remote one or use GitHub or Azure DevOps, for instance. This could also be a private repository. So if you want to save your code to the cloud, feel free to do so. As mentioned earlier, you will find the code of this course on GitHub as well. So if you have any trouble or just want to play around with the project, feel free to access this project on GitHub, clone the repository, fork it, star it, and so on. Alright, that's it for this section. Let's make a game now. You have already seen lots of code. Now it's time to write some by yourself. Welcome to Blazor Battles, where you learn how to build your online browser game with Blazor WebAssembly, Web API, and Entity Framework. In the beginning of making this game, we will focus on the client part. There might be some situations where a web service call would make sense, but we simulate that call by using local variables or methods first. Later, everything will come together when we add the Web API and Entity Framework with a SQLite database. But let's talk about the actual game now. The very first thing we need in a browser game are resources. To make things easier for us and the players, there should only be one resource, and this one and only resource shall be the banana. With bananas, a user is able to build units. The units that will be available are knights, archers, and mages. They have different strengths and weaknesses and consume different amounts of bananas. With these units, a player creates an army, and with that army, a player is able to fight battles against other players, hopefully win them, and eventually get to the top of the leaderboard of Blazor battles. By building this game, you will learn lots of stuff regarding Blazor WebAssembly, Web API, and Entity Framework. We will start with a new Razor component, use data and event binding, and then move on to communication between components. I think I've said enough, let's create the new Razor component next. Now, since bananas are pretty important to our game, let's create a component that shows the current count of bananas. Please note that everything we're going to build in the upcoming lectures assumes that we are working with an authorized player. Actual implementations regarding authentication will come later. Doing it that way is a lot more fun in my opinion. Anyways, the component we're going to build should be seen by the user all the time, so that the user always knows how many bananas are available. So let's build a top menu for that. So in the shared folder of our client project, we go to add and then Razor component, and we call this thing top menu. Alright, and now in the code block we can already create a property, public int bananas get set, and by default this is 100. And now to display this value we have to use the data binding of Blazor assembly by typing @ and the name of the property or the variable. So here we simply say @bananas and remove the top menu here like that. That's it. Now we have to add this component so that we can actually see it. So we go to the main layout, and here instead of the about link we simply use our component by typing top menu, and we can also already close this, and that's it. Now let's have a look. We see in the package manager console my application is still running. If this is not the case for you, just type .NET watch run again, and then the app will be rebuilt, and then you can go to Chrome and have a look at your application. Let's go to the home page and reload this thing. And right here, far to the right side of the screen, we see 100. Well, that's nice. I'm not a designer, but still, let's make this a little bit prettier. First, I would like to add some icons. You can get them from the resources of this lecture or the GitHub repository. We will only use the banana icon now, but later we make use of the others as well. To be able to use icons, we create a new folder in the root folder and paste them there. So back to the IDE, we add a new folder, call it icons, and then when you've downloaded them you can just copy and paste them here, and now we've got them in our project folder as you can see here. Okay, and after that we go back to the top menu component and then we write some HTML. We add a div first, and then we add an image where the source is, icons, and then the bananas image, and we have to remove this stuff here because it does not work with Blazor. And then we add the bananas variable. Okay, now how does that look? We go back to our page, and here's our banana. Sweet. Now there's one little thing I'd like to add, and that would be a little CSS. So let's add the class top menu to the div. Top menu, save this, and then in the app CSS, we add a little style. So again, the class top menu, and let's say we want to center this thing, give it a width of 100%, and display is flags. Okay, reload the page again. Better. Now one last thing, to see the bananas also when the responsiveness of the app kicks in, we make another little change in the app CSS. Down here, we just remove the display none, like that. Okay, and now when we reload the page, we see the banana, and when we open the console and change the view, we see that we still see the bananas. Great, you've got your first component. Now let's commit this and then move on to the next lecture. When you're creating a Blazor application, you will get to a point where you want components to communicate with each other rather quickly. The easiest way to communicate values from a parent component to a child component is via parameters. You have already seen this in the example code. Now we want the main layout, which is the parent component, to tell the top menu, which would be the child component, how many bananas the current user has. We do that with a parameter. So in the top menu component, we add the parameter attribute to the property. Parameter, there it is already. Simple as that. And this, by the way, is also the reason why we're using a property here instead of a private variable. A private variable can't be a parameter. That's one thing to think about when you're designing your application. Now with that change, we are now able to set the bananas value in the main layout. So we go to the main layout, which is already open here. And here we can simply set bananas, now it is available, to 200, for instance. Back to Chrome, and maybe change that again, and reload the application. And we see now that we have 200 bananas. Great, that's it already. And now let's see how communication works the other way around, meaning from child to parent. Communicating from child to parent in our case would mean that a component that has been added to the top menu would tell the top menu to change the value of the bananas, for instance. So let's create a new component called add bananas, which will simply be a button that increases the value of the bananas. I know the player shouldn't be able to just add new resources whenever he or she wants to, but let's ignore that fact for now and try to continue learning. So we create the new component. In the shared folder again, we click add razor component and call this add bananas. Okay, and maybe now let's first add a button that does simply nothing, and then we already use that component in the top menu. So first the button, which also gets class. And since we're using Bootstrap here by default, we can use all the Bootstrap classes. For instance, the button info class. And this thing gets a plus button, a plus sign, like that. And now back to the top menu. We are going to use the component like that, add bananas. Okay, now let's have a look. Sweet, we see a plus button. Okay, now that we got the button, real quick, just add a span to the bananas value so that it looks a little bit better, and give this thing a class called popover header. And have a look. Yeah, better. Much better. Okay. With that out of the way, now we want that button to change the value of the banana. So how would we do that? Well, we cannot simply access the bananas property of the top menu. Instead, we have to raise an event, and when this event is fired, the top menu itself decides what to do. But let's build this thing one step after another. First, we need an event callback property in the add bananas component, which is also a parameter. So back to the add bananas component. Now in the code block, we add a new property. This time I used this built-in snippet prop. You just enter prop, hit tab, and then you got your property. And this thing is again a parameter. Now the return type is an event callback with the type of the value, which is an integer, and we call this thing bananas added. This is actually the event. Bananas have been added. And we save this. And now we have to invoke this event, and we do that with a method. So public void increase banana count, for instance. And now we access our bananas added event callback and call the method invoke async and give this thing a value like 10, the integer. And please ignore for now that this is an asynchronous method. Okay, and now the next step is we need something that calls this new method. What about our button, for instance? So we go to the button and bind to the onClick event with add onClick. And here we call the method increase banana count without any brackets or any value, just like that, only the string of the method. Okay, we save this and we are almost done. Now in the top menu component, we also add a new method which will change the value of the bananas property. So to the top menu now, we add the method public void add bananas with again an integer value. And now the bananas here, our property, will be increased by this value. Okay, and finally, we add the bananas added event, the parameter, to this method, add bananas. You see that the top menu does get the value of the fired event, so that it can actually use it to change the amount of bananas. Now let's recap what we've done here. The add bananas component, this one here, gets an event callback property, which is also a parameter. When the button is clicked, this event callback is invoked with the help of the increase banana count method. Now the top menu component also needs a function which is called when the event is fired. We set this up by using the parameter of the add bananas component right here. Again, because maybe this is a bit complicated, we have an event. When the button is clicked, we call this method here, invoke the event with a value, and then the top menu component has another method which is just a helper method to actually set the value. And then the component is integrated here or added here with the parameter BananasAdded to call this method here with the value. Okay, we saved everything. Now let's have a look. We go back to Chrome. We reload the page. And now we just add some bananas. And you see this works just fine. Great. Now, before we have a look at the third way of communication between components, let's create a new page first, because that way we can change the banana count of the user, although we're not a parent or a child of the top menu component. In this game, we want to build an army of units like knights or mages. To build these units, you need bananas. The thing is, we don't want to build our units in the top menu. We want to build them with a separate page. So let's create this new build page, which is another Razor component in essence. So in the Solution Explorer, now in the Pages folder, we add a new Razor component. And we call this thing build. And since this is a page now, we can also already add the page directive with the route build. Okay, great. And now let's add a link to that page in the nav menu. We go to the nav menu component and we can just copy this one here, for instance, the counter page. And now here we replace the name, also the route, and maybe the icon. We can use a wrench for that. And now let's see how this looks already. Okay, great. We got the new menu entry. And now when we click build, we get to our build page. Okay, and while we are already at it, let's clean up a little. We don't need the counter and the fetch data link, so let's just remove them. And we can also change the title here, Blazor Battles. And let's do the same to the index Razor page. Remove this one here. And this thing, and here we can say welcome to Blazor Battles. And the last thing I want to change is the index HTML, because there's also a title. Just add a space and that's it. And now let's have a look. Title works and the home page works as well. Great, much better. Okay, back to the build page. The plan is to have a drop-down where we can choose a unit we want to build and a button that finally builds that unit. Now let's focus on that button first. We can already add it and call a dummy method when the button was clicked. And the idea is that when we build a unit or click that button, that bananas will be consumed or eaten. So maybe first add a method called eat bananas with an amount of bananas, and before we actually consume bananas, let's just log something into the console, and we do this with console write line and then a little string where we say amount bananas eaten, something like that. And now we add the button that will call this method. So we give this thing a name, eat bananas, and then bind again to the onClick event, onClick. And now we've got a little problem here, of course. We cannot just use the string of the method because we want to also give this method a value, the amount of bananas. So when we want to do it like that, eat bananas, this won't work. So what we have to do, there's another way to actually call this. We can add this lambda expression here, and now we can give the value to the method. That's it. Okay, let's see how this works now. We reload the page, go to build, and also go to the console and click eat bananas. Perfect, we see that 10 bananas should be eaten, but of course the value hasn't been changed. Now to fix this, we have to add a service. So let's create one next. When we are creating a service, any component can inject this service and access its methods and properties. So the build page, for instance, could call a method of this service to decrease the amount of available bananas, and the top menu component could access the current amount of bananas which is provided by that service. The crucial part is notifying the top menu component that the amount of available bananas has been changed. To realize that, the top menu component has to subscribe to an event of the service. But let's implement the service first. We create a new folder in the client project and call this folder services. And now for this new service, we first create an interface and call this interface BananaService. This thing will be public, and we add a property int bananas get set, and also add a method eat bananas with an amount of bananas, which is an integer. That's the interface. And after that, we can create the implementation class, of course. So we add a new class, the BananaService, and this thing now implements the iBananaService, and we can also implement the interface. Now what I did is I hit Control and period on the keyboard, or you can use this quick fix menu here to implement the interface. But I think it doesn't really work fine with the properties. That's a bit too much, and that's what I wanted. Okay, so we've got the interface and the implementation class, and now we can say that by default we get 1,000 bananas, and the method eat bananas just decreases the amount of bananas here. Okay, that's nice, but we have to add an event of type action now as well, and also a method that invokes that event when bananas have been eaten. So let's do that next. Back to the interface first, we add the event action on change. And now in the service, we also add this thing, public event action on change. And then we add another method, call this bananas changed. And this does only one thing, on change invoke. Okay, so we got the new event on change, and then we added the method bananas changed, which invokes this event. And then when we actually change the banana count, we call the bananas changed method. Okay, and now to be able to inject this service, we first have to register the service in the program CS file. So we go to the program CS, and down here we call builder services add scoped. And then we tell this method that we want to add the BananaService and that the corresponding implementation class will be the BananaService, like that. And then we add the using directives Blazor battles client services. And that's it. Okay, and now we can go to the build page, inject the service, and call the eatBananas method. Now in the build page, we inject a service with @inject. We find this thing in Blazor battles client services BananaService and call this thing BananaService. And now we replace our console write line with BananaService eat bananas amount. Alright, and now the last step would be the top menu component, which now should display the bananas of the BananaService. Now again, we have to subscribe to the onChange event of the BananaService to do that. So we go to the top menu, and up here we inject the BananaService again. Blazor battles client services BananaService. And then what we do is we subscribe to the onChange event of the BananaService. So first, protected overrides void on initialized. And here we say BananaService onChange, and then we subscribe with the state has changed method, which notifies the component that its state has changed. So that's how the component knows that it should re-render itself and display the new BananaService. Okay, again, the onInitialized method is part of the component lifecycle, so that's why we have to override it. And then on initialization, we can subscribe. There's one more thing we have to do. Additionally to subscribing to the onChange event, we also have to unsubscribe on dispose. So we have to implement the iDisposable interface for that and unsubscribe in the dispose method. So first implements iDisposable, and then down here we add the method public void dispose, and then we simply say BananaService onChange minus equals state has changed. Okay, now lots of code has been written. Let's see the result in a minute. First, let's recap. So what did we do? We added the BananaService, an interface first with these properties and the method. We have the onChange event, the bananas property, and the eatBananas method. Then the implementation class. Still the onChange event, which is invoked. Then we have the bananas property, by default 1000 now. Of course, that's up to you what you want to set this value to. And then the eatBananas method, which will simply change the value. And the most important thing here is that the invoke is called. Then we have the build Razor component, or the new build page, which injects the BananaService, and we will talk about dependency injection later. But now with this BananaService, we can call the eatBananas method with this given amount here, and then the top menu component subscribes to the BananaService onChange event, and this is done on initialization right here. Now, did we forget something? Yes, of course, because here we are displaying still the bananas of this property here, but we actually want to display the bananas of the banana service. Otherwise, this whole thing wouldn't make any sense. So we just add the banana service here and access the bananas of the banana service. Okay, everything is saved. Let's have a look. We reload the page. We've got 1,000 bananas now. You see that we are now displaying the bananas of the banana service, and we eat them, and now we've got 990. Can eat even more bananas, and this works just fine. Great. So eating bananas works, but adding bananas doesn't work anymore. So let's implement that next. All right, now first let's clean up a little. There are some parameters we don't need anymore, like for example, bananas added. This we can remove. The same states for the main layout. We don't need this parameter anymore. And also now the code can be changed. So in the top menu, we already removed the parameter in the add bananas component, and then we can also remove this parameter here and also the add bananas methods, because we will add the bananas now with the help of the service. Okay. And in the add bananas razor, we can also remove the event bananas added now. And also remove this line here. Okay. Now, since the event doesn't exist anymore, we have to implement something else for the increase banana count method. You might have already guessed it, we need a new method in the banana service, and you use this method here in the add bananas component. So first, let's go to the BananaService interface, and we add the method add bananas with an amount, like that. And now in the banana service, we implement this thing. So public void add bananas and amount. And similar to the eat bananas method, we change the value bananas plus equals this time, and we call the bananas changed method. Now back to the add bananas razor component. Again, to be able to use this new method, we have to inject the iBanana service. So inject Blazor battles client services iBananaService banana service, and then down here we call BananaService add bananas with 10, for instance. All right, that's it. Let's test that now. Reload the page and add some bananas, and it works. Again, what we did this time was we added a new method to the interface and to the service, where we now increase the amount of bananas, and then the add bananas component injects the banana service again and uses this method, and we see the value again because of the onChange event, and that's why it's important to call the bananas changed method here, which will invoke the onChange event again, so that the top menu knows, hey, I have to re-render myself because the banana service bananas value has been changed. Perfect. So now we can add and remove bananas from any place we want, and we always see the current amount in the top menu. All right, now the next step is to actually build some units instead of just eating bananas with no result. For that, we need new models or classes, in other words. You have already seen the weather forecast class or model of the example implementations. So we can use these models in both the server and the client project to do anything we want to do with them. To build units, we first need a unit model. The idea is that with the unit model, we define the different kinds of units we want to make available in the game, like a knight or a mage. So let's create that model now in the shared project and give it some properties. In the Solution Explorer, this time we go to this shared project down here and just click Add Class. And this thing is called Unit. And this thing is also public. And now it's getting some units. As already mentioned, you can simply use the prop snippet. The first thing is indeed an integer, and this would be the ID. Next, we've got a string, which is the title of the unit. Then we've got an integer again, which is the attack value. This will be used for the fights later in that course. Then we also got something like the defense value. We've got hit points, which we can already give a default value of 100. And then we've got the banana cost. So how many bananas do you need to build that unit? So this is the definition of a unit. Now, when a player or a user builds a new unit, there should be a representation of that particularly built unit for that user. So we need some kind of mapping model to store the complete list of units the user has built. Let's add a user unit model next. So again, in the shared project, we add another class. Call this user unit this time. Also public. And here we only need first the property user ID, which I have to admit doesn't make a lot of sense for now, but it will later, trust me. And then we also give this thing a unit ID, which will be the ID of the unit we just created. And then also I want to store the hit points here, because later in that course or later in that application, when units or armies fight against each other, the hit points will be decreased, of course. Not every unit will be killed after one hit, so we have to store the hit points separately here. Okay, great. These are all the models we need so far. Now let's implement the unit service where the building magic happens next. We start with the unit service interface. It will have a property that defines what kinds of units are available to build, another property which is the list of all the units the current user owns, and a method to add units to that list. So back to the client project. We add the interface first. Interface unit service. So again, we need something like a list of units, which are the available units, and we only get them first. Then we've got a list of user units. Let's call this my units, which can also be set. And then we've got a method called add unit. And here we just want to give the unit ID to this method. And here we have to use the shared project for the models. So that's our interface. And now let's create the implementation class. Services, add class, unit service, and this implements the interface. Implement interface. our units, and again I have to remove the not implemented exception. Okay, now the first thing I want to add here are some mock units. Later we will have them stored in a database and receive the units from the database, but for now it would be easier to just define some units right here. So we create a new list of units. We add a new unit and give this thing some properties. First the ID 1, then the title, a night, attack value is 10, defense value might be also 10, and then the banana cost of a night might be 100. And now let's copy this and add 2 more. So now we have the ID 2, title is an archer now. Maybe give it a bit more attack, but less defense. And the cost for an archer should be 150. And the last thing is with ID 3, mage, even higher attack, but lower defense, maybe even only 1. And the mage costs 200 bananas. Okay, so now we've got the units. Now let's also set the my units list to a new list, because this will be the army of the user. So my units is a new list of user units, and then the add unit method, which will get the ID of a unit and then add a new user unit to the my units list. So we first get the unit from the units list. First unit where the unit ID equals the given unit ID. And then the my units list, we add a new user unit where the unit ID equals the ID of the unit, and the hit points will be set to the unit hit points, like that. Okay. Now, please note that this might not be the best design decision. We are not adding a new unit to the units collection. We're creating a new user unit and add it to a user unit list. So maybe we should use some kind of user unit or army service, because these objects will be the army of the user in essence. However, to keep things simple, I'm fine with this conceptual flaw for now, but we will change that later when we implement the backend. Okay, now finally we register this new service in the program CS file. You did this already with the BananaService, and now we also do the same with the new unit service. So unit service and the implementation class unit service. All right, now it's time for the last piece of the puzzle. We've got the models and the service, and now we can use both in the build component. So let's do that next. The first thing to do is injecting the new unit service. So on top, similar to the BananaService, we write add inject, then Blazor battles, client services, and then unit service this time, and we call the service unit service. Then we move to the code block. We can actually remove the add bananas method first. And now regarding the HTML part, I want to use a select box to choose the unit that should be built. The selected value of that dropdown will be the unit ID. This means we need a variable we can bind this unit ID to. So let's add a new variable and call it selected unit ID. And this is an integer, selected unit ID. And the default value can be 1. And now let's add a new method, public void build unit, which we will use to build the units in essence. Now here we first grab the complete unit with all its values with the help of the unit ID. So we have the Blazor battles shared unit, which will be the selected unit. And here with the help of the unit services units, we grab the first or default where the unit ID is the selected unit ID. Now we've got all the information of that unit and can use the banana cost to decrease the current banana amount of the user by calling the eatBananas method of the BananaService. So BananaService eatBananas, and now we grab the selected unit and the banana cost of that selected unit. And then we add this new unit to the user units. So unit service, add unit, selected unit ID. Great, so far the code block. So we have the selected unit ID and then the method build unit where we grab the selected unit from the unit service with the help of that selected unit ID. Then we decrease the banana values of the user with the help of the BananaService. And then we add the new unit to the my units list of the current user, again with the help of the unit service. Now we add some HTML. The button calls the build unit method now, and we can change the text of the button as well. Build unit, and we just change the text to build, and we can also give this button a class again, button and button primary. Okay, and now the select box. As mentioned, it will bind the selected unit ID, and with a for each loop we will display all available units. So first we create div, and this div gets the class form group to make this a bit prettier. And then already we've got our select, and here we can use bind, add bind to bind to the selected unit ID of the code block. We give this thing also a class form control. And now the exciting thing, we can write some C# code inside of the HTML with the add sign, and then add the for each to make a for each loop. And we say for every unit in unit service units, we want to do something. We want to display the unit as an option in the select box. So option value would be then at unit ID, and this unit here now is the unit of the current iteration of the for each loop. And we can also use any property of this unit, like the title, for instance. And of course, the banana cost, and then add the text bananas, and that's it already. So again, we add a little div to make this thing a bit prettier. And then we already create our select box, our drop down. We use the add bind here to bind to the selected unit ID. And then we can use the foreach loop inside of this HTML to iterate through the units of the unit service, and then use the properties of the unit variable in this case to set the ID to the value, which will then be set to the selected unit ID, and also display the title and the banana costs. And then with the build button, we will call the build unit method, and the build unit method will choose the selected unit ID to eat bananas and add the unit. Now, to see a result so far, let's add a little output to the console in the add unit method of the unit service. So back to the unit service, here down in the add unit, we just write something like write line. And then unit title was built, and console write line your army size, and then we just display the count of the my units list, because until now we don't display the army in the client on any page, but we'll do that later, of course. So maybe just log them into the console. Okay, perfect. Let's test that now. Back to Chrome, we reload the page. Maybe make the console a bit bigger again. And as you can already see, we have a beautiful drop down here, and the build button looks a bit better now. We have 1,000 bananas, so we would expect that when we want to build a knight, the bananas would be decreased by 100. Let's build the knight. Perfect, we have 900 bananas left. And we see that the knight was built and our army size is 1. Now what about an archer? Works. And the last one, the mage. Perfect. But now the thing is, we can build as much as we want. So this works like a charm. We are able to build our army, but as you can see, there's still some work to do. We have to add an error message and block the building of units if there are not enough bananas left. And it would be nice to see your army on a separate page, of course, instead of the console. So let's create this page next. So let's create the new army component, which is also a page first. We go to the Solution Explorer, right-click Pages, add Razor component, and call this component Army. Okay, and already on top we can add the page directive with the route Army. And next, since our units are stored in the unit service, we inject the unit service. So again, inject Blazor battles client services I unit service. And now we write a mix of HTML and C# again. We display all our units in a list. And wouldn't it be nice to show a matching icon for every unit? And also maybe show the current hit points. So let's do that. We start with an for each again. And now we want the user units. So in the unit service, we grab the my units list. And now we create a div with the class army lists, which I will add in a second. And now we add another div. And then we will use a switch case, which will look at the unit ID. And we have the IDs 1, 2, 3, remember? So in the case of ID1, we already add an image where the source is icons, and this will be a knight, so maybe use the sort and then add break. And again, we have to remove this because it doesn't work here with Blazor. In the case of ID2, we have the image for an archer, or the icon for an archer, and this bow here would make sense, I guess. Break, remove this, and in the last case, which would be 3, we have the mage, and for the mage we use the head. Break. Okay, so we have our icons for our units, and next would be the title. So what kind of unit is this? And for that we access the unit service again with the @ units first, and then unit ID is the user unit ID, and then we grab the title of this thing. So with the help of the unit ID of the current user unit, we are getting the unit of all available units, and then just get the title and display this one. And the last thing we want to display are the hit points. And for that, again, we access the user unit and just show the property hit points with the text HP. Okay, that's it. The code block can actually be left empty this time. And now we have to be able to open that page, of course. So let's add a new nav link in the nav menu component. So in the Solution Explorer, or this time maybe to do it another way, I press Ctrl and P and then just search for the nav menu. And here I already am. And now I can just copy this thing here and add the new list item for the army. The route was army, and also the text here is army. And we can change the icon and choose people, for instance. Okay, now let's see how this already looks. In Chrome, we reload the page. We've got our army menu entry here. Click it. Of course, we don't see any armies now, but when we build a knight, for instance, an archer, and also a mage, and then we go to army, perfect, we see our army. Well, it's not very pretty, of course. Maybe we can put the whole unit in one line, so let's add some CSS. So in the app CSS, under the top menu this time, we add the class army list. We have already added to the div earlier, and this thing gets display flags, justify content space evenly, and also we add a little padding of 10 pixels. Save this. And maybe we can also remove the output in the console in the unit service. So in the unit service, these outputs here, let's just remove them because now we see our army. Okay, let's have a look again. We reload the page and we have to build new units first because the app has been restarted, and then we watch at our beloved army. So let's just add some knights, archers, and mages. Beautiful. Now, we've already seen that the amount of bananas doesn't really stop building new units. When the amount is below the cost of a unit, you can still build it. We should definitely change that and tell the user that there are not enough bananas available. Additionally, when we currently build a unit, we don't get any feedback. Maybe some kind of pop-up, a message, or a so-called toaster would be nice. So let's add that next. Now, the easy way to display an error message would be a little div that is shown if a certain condition is hit. Let's try that first. So we go to the build component. Below the button, we add an if condition with a variable like need more bananas, and we will add this variable in a second. If this is the case, we show a little div with the class validation message. This is already available. This just means that the text will be read, so nothing too special. And we will add the text not enough bananas, which is really sad. Okay. And now we switch to the code block, add the boolean variable and set the value property in the build unit method. So first, the need more bananas variable. So bool need more bananas is false. And then in the build unit method, we add another if condition, BananaService. Bananas is below the selected unit banana cost. And in this case, we set need more bananas to true and then just return from that method. And in the other case, need more bananas will be set to false. Okay, let's test that already. We go to the build page, reload. Let's choose the mage, build a mage. And what happens now? Not enough bananas. Sweet, this already works like a charm. And we cannot build any more units. As you can see now, the knight, for instance, I can't do anything. And the knight has not been built. I only have mages here. So the error message appears, and when we add bananas or reload the page, in this case, it disappears again. But let me add more bananas now and build the knight, then the message is gone. Perfect. But I promised to add a toaster message to the game, so let's do that next. Now there is a beautiful library by Chris Sainty called Blazored.Toast. We can use it to display our toaster messages, and to use that package or install it, we can install it with manage NuGet packages. So let's do that, but first we have to stop our application. So in the package manager console, we can stop it, and then we right click the client project and choose manage NuGet packages and search for the package in the browse tab, Blazored.Toast. There it is already. That's it, Blazored.Toast by Chris Sainty, and we will install the latest stable version. Just hit install and you're good to go. Now, if for some reason any errors or warnings occur in your case after installation, it might help to rebuild the whole solution. So just go to the Solution Explorer, right click the complete solution and hit rebuild solution. Sometimes this happens, but now we have to add some configurations before we can use this new package. So first we have to go to the program CS, and here we have to register the new Toast service and add the corresponding using directives. So up here we first say builder services add Blazored Blazored.Toast. As you can see, Visual Studio doesn't know what this is, but we can choose using Blazor.Toast in the quick fix menu. And now we got the using directive, so everything is fine here. Now next is the index.html. In our root folder, there's the index.html, and here we have to add another style sheet. So up here we say link href, and now it's underline content Blazored.Toast, and we choose the Blazored.Toast min CSS, and this is a style sheet. Okay, so content Blazored.Toast Blazored-Toast.min.css, the minified version. Next we go to the imports and add the toaster here. So this would be Blazored.Toast and also using Blazored.Toast services. And now the last thing is the main layout, because we will use the Blazored.Toast messages, or we want to use them everywhere in our application. So what we do is we add the Blazored.Toast configuration here, and then also add the component Blazored.Toasts. So now we can use the toaster everywhere we want, and it'll always be displayed on top. Okay, that's it. Now let's start with the build component. In the build razor on top, we first inject the toast service now. And since we have added the toaster to the imports razor file, we can do it like that. Just inject I toast service, and the component now knows what the toast service is without adding all the other namespaces. So this thing is called toast service, and then we use it in the case that we don't have enough bananas. So down here now in the build unit method, we add the toast service and a method like show error with the same text, not enough bananas, and the title is the sad smiley here, like that. That's it. We did the whole configuration part, added the toaster. So let's save this, and now it's time to test that again. But remember, we have to start our application first with .NET watch run in the package manager console. And when the application has started, we can go to Chrome and try to build more units. Okay, we built a knight. And then let's try to add more mages. Not enough bananas. We've got 100, but we need 200. Perfect. We see the toaster. The same works for the archer. We get another toaster message, but the knight would be built. Perfect. Okay, this works like a charm, but what about a success message, for instance? Let's do that next. Adding a success message looks a little bit different in the case of building a new unit. Now, why is that, you might ask? Well, the error message was created in a Razor component, but adding a new unit happens in the service. Hence, the success message should be created in that service as well. So we have to inject the toast service in the unit service, and to do that we need a constructor first. So we go to the unit service, and now on top we add a constructor. Again, we can use a built-in snippet, CTOR, and then hit tab twice. And now in that unit service we have to inject the toast service. So I toast service, toast service, and we need another using directive here using Blazored.Toast services. And then what we can do again with the quick fix menu, so just click the light bulb or hit Ctrl and period on your keyboard. We say create and initialize field toast service. So the toast service is available in the unit service here. And what I'd like to do is add an underline here because this is a private read-only variable now. And now we are able to use the toast service in the same way we used it in the Razor component because it is injected. So we did not use a directive like add inject, but this is how you inject the toast service in the unit service. And you will see that in more detail later when we're in the backend, and there I promise I will talk about dependency injection a bit more in detail because this is what we actually did in this case. But don't worry about that. Let's focus on Blazor now and the toast message. So down in the add unit method, we can now use the toast service with show success in this case, and we add something like your unit title has been built, and the title of this toaster could be unit built. Okay, so we access the toast service and then call the show success method to show a success message. That's it already. Time to test it again. Back to Chrome, reload the page. We have 1,000 bananas, we build a knight, and there's our success message. Your knight has been built. Perfect. Now you know how to use any kind of toast messages anywhere you want. Congratulations! You learned a lot in this section. You have made your very first steps with Blazor WebAssembly. We started with an overview of the whole solution with its client, server, and shared projects. Directly after that, you created your first Razor component by yourself and learned all kinds of ways how components are able to communicate with each other and how to use data and event binding in Razor components. Parameters, event callbacks, and services are nothing new to you anymore. After that, we created new models to build units like knights, archers, and mages. To do that, we also created new services and utilized a drop-down list and a for each loop to choose the unit the user wants to build. Then we created a new page to display all the units of the user and also added toasters to give the user feedback of the building process. You are now able to display error and success messages to the user. Next up, we will cover forms and authentication in Blazor WebAssembly. Welcome to the Forms and Authentication section of the Blazor WebAssembly Bootcamp. In this section, you will learn all the parts that are necessary to register and authenticate a user. First, we will start with edit forms, built-in forms components, and validation. With that, we will create new models and use these models with these forms. After that, we will dive into the authentication. How does our web application know that a user has been authenticated and that this user is authorized to view a certain page? By answering this question, you will use the authentication state provider, the authorized view, the authorized route view, and so on. Additionally, we will utilize the local storage of the browser and in the end clean up the navigation so that our browser game will look different depending on the current state of the user. Let's start. We start with creating a simple login form. In this section, we will kind of simulate the authentication of a user because there will be no web service call. We will add one later when we implement the web API with Entity Framework, of course. But for now, let's build a login form and simply authenticate the user with any credentials. To add a form, we use the edit form component, and an edit form needs a model to map its form components, like input fields for example, with the corresponding properties of that model. So let's create a simple user login model in the shared project. So now in the shared project, we add a new class and call this user login. Make this public, and this user login model is quite simple. We have a string with a username and another string with a password. Now we can already make use of the built-in validation feature here. Just add the attribute required on top of every property, and we'll see in a minute what effect this attribute has. So required on top, and the same here for the password. Now, as you can see, Visual Studio doesn't know what this required attribute is, so we have to install another package. As you can see down here, we are offered to install the package system component model annotations. So let's do exactly that to be able to use this attribute. Just select this entry and then find and install latest version. Okay, perfect. Now it is installed. Now this is just another way to install this NuGet package. As you have seen before in the section before, we could do it by manage NuGet packages and then install the package manually, or we just do it that way. Okay, so we've got our model. We're using the required attributes. Now let's create a new page, the login page. In the Solution Explorer, and now again in the client project, right-click Pages, add Razor component, and we call this a login. And since this is going to be a page, we add the page directive and also the login route. And now here we can use the edit form component to build the login form. Edit form. And now the edit form takes two arguments, a model and a function for the event on valid submit. There are also the events on invalid submit and on submit if you want to run a validation by yourself, but let's keep things simple at the beginning. So we have a model, which we will add in a second, and also the on valid submit parameter. And this as well we will add in a second. First we add the model and the method in the code block. So this will be a private variable of type Blazor battles shared user login. This is the user, and this is a new instance of the user login model. And then we have a method private void handle login, for instance, which is empty first so that we can add it to the edit form component. The model now is the user, and on valid submit gets the function handle login, like that. So again, we have added the user model here, the user login model, and the handle login function, and this is used in the edit form so that the edit form knows, okay, my model is the user, and we have the properties username and password, and the method to call on a valid submit is handle login. Okay, and now we can use the built-in forms component input text to create our input fields for the username and the password. There are more forms components, of course, and we will use them in the registration lecture. Okay, now apart from just using these components, let's try to make this form a bit prettier by using some more tags like a paragraph tag and the label and so on. You will see it along the way. So first we have the username, and we will use the label tag here. And now in a div, we will use the input text component. Now this is a built-in forms component of Blazor WebAssembly. The ID in this case is username. And now we want to bind the content or the value of the input text to the property of the user model. So we use @bindValue and tell this input text component to bind to the username of the user model. So this would be the first one. And then we add another paragraph with the label password and also another div. And now we have another input text with the ID password. And then we also add the type password so we don't see the plain text. And we bind to the value user password. Like that. Okay. And now at the bottom, we add a button for the submit function. So a button. The type now is submit. We can also add the class button and button primary again. And we give this the text login. So again, we have the edit form using the user model and the handle login method of our code block. And then we just add some HTML. We are free to use any kind of HTML here in essence. The most important parts are the input text component here, which binds in this case to the username of the user login model. And this thing here binds to the password. And in the end, we need a button with type submit so that the handle login method is called. Okay, and now maybe we can also log the entered username and password in the console so that we see an effect. So down here, just write console write line. And then, quite simple, just add the username and also the user password, just to see that this thing actually works. So we save this, and now we can already test this, I'd say. So we go back to Chrome, reload the application, and now we have to enter the route manually in the address bar. So just add login, and there is our form. And now we can test that already with the top secret password. Hit enter or click the login button, and we see that this works. Our handle login method is called, and we log the username and the password in the console. Now the thing is, when I remove the password and click login, it still works. So what about validation, and what about actually authenticating the user? Now to use the validation, we have to add the data annotations validator component. So back to Visual Studio, just below the edit form, we add data annotations validator. And that's already it. When we now try to log in with an invalid form, the invalid control gets a red border. So just reload the page. And when I now hit login, you see that this thing gets a red border. And if I add a username, then the input text is now green, but the password is red. And now when I click login, both are green, because the only attribute we added was the required attribute. So this form is valid as soon as something has been entered into the input text. Now we can also display an explanatory text for the validation. And to do that, we have to add the validation summary component. So again, back to Visual Studio, and now maybe below the button, we add validation summary. And now we should see some explanations. Why are why is the form invalid? So let's reload the page and click login, and now we see the username field is required and the password field is required. And if I enter a username here and hit login, then only the password field is required, is the only error message left. Nice. Now we can also enter a custom error message, of course. Now to do that, we go to the user login model, and with the required attribute, we can give this thing an error message like, please enter a username, like that. Save this, and again, let's test that. And when I now try to log in, I see please enter a username for the error message. Nice. Now, but what about actually logging the user in? Well, actually, you would use the authentication state provider for that, but we're not ready for that yet. Let's simply use a variable that stores an authenticated state and change the content on the login page accordingly. So back to the login component. First, we add set variable like bool is authenticated is false in the beginning, and in the handle login we just set this to true. And now what we can do is we can add an if condition right on top, and now we just say if is authenticated, we want to display something like welcome username, and in the else case we display the login form. Okay, I know this already doesn't really feel right, but let's test this nonetheless. I log in, and now I can enter whatever I like. Well, you see, this kinda works, but it doesn't really feel right. We are still on the login page, and the whole time the top menu did not change. So there's definitely a better way to handle this, but before we get to that, let's have a deeper look at the built-in Forms components with the registration page. Now, as you can see here, the added form of Blazor WebAssembly provides the following built-in form components. We've got an input checkbox, an input date, number, select, the input text, you've already seen that, and the input text area. We will utilize all of them for the user registration, but before we can do that, we need a model. And with that model, we will also use more validation features. So let's close this, go back to Visual Studio, and then create the new user register model. And we will use new validation attributes as well, and I will explain these along the way. So first, the new model, add class, and we will call this user register. Make this public. And now we add a bunch of properties. So the first thing I would like to add is a string and an email address, which would be an input text. Now the next thing is again the username. Then we've got another string, the bio. This is something where we could use the input text area. Then something we already know, the password, of course. Then we add another password field to confirm the password. So these two have to match, and we will use validations for that. To use an input number field, I want to give the user the opportunity to add some bananas with the registration. Then to use a date, we just add the date of birth. And to use a checkbox, we use something like is confirmed. So usually maybe you would need to confirm your registration with another email, but in this case we just add a checkbox for that. Okay, so we've got the email, the username, the bio, the password, the confirm password property. We've got the bananas, the date of birth, the confirmed, and I think I forgot one thing, which would be another string, the start unit ID. What do I mean by that? I want to use the input select for choosing a unit the user wants to start with in essence. And although this is an ID, we have to use a string as the type because the input select can't handle integers yet. Okay, these are all the properties, and now we add some attributes for the validation. So the email address is required, and we can also add email address as an attribute because then the form will check that the user has entered a valid email address. So we don't have to worry about that anymore. Now the username is not required anymore because we want to log in with the email later. So, but what we can do here, we can use the string length attribute and say that the max length of a username is 16. And we can also add a custom error message like your username is too long, 16 characters max. Okay, we can leave out the bio, but the password of course has to be entered, so this one is required. And we can also add the string length. For instance, say max string length is 100, but also add a minimum length of 6, for instance. Okay, and then the confirm password, here we can use the compare attribute and add the password property as a string so that we want to compare the confirm password property with the password property, and also add another error message that says the passwords do not match. Then regarding the bananas, I don't want the user to be able to add million bananas, but maybe something like 0 to 1000. So if the user wants to start with a little help, he or she can just add 1000 bananas. And also we add an error message that says, please choose a number between 0 and 1000. And now the last thing I want to add is an attribute to the isConfirmed property. Down here we only want to have a valid form when isConfirmed is checked, so when the value is true. Now this looks a bit strange maybe, but what we can do here is also add a range and say this is type of bool, and the only range we accept is from true to true. As I said, it looks a bit strange, but this actually means that the form is only valid when isConfirmed is set to true. So only confirmed users can play. And by default, because I'm lazy, we set this to true as well. And let's also initialize some other properties, for instance, the date time now, just by default, so it wouldn't be null later. This is a night in the beginning, and maybe here we add 100 at first. Okay, I think that's it. Now we've got quite some fields to fill out, so let's create the form for registration next. So we create the new registration component as a page. So add razor component, call this register. This thing is a page with the route register, and we can then start with the code block. We add a model again, similar to the login, and also a method that is called onAValidSubmit. So first, Blazor battles shared user register this time. This is our user. And this is a new user register instance. Okay, and now the method void handle registration. And again, first we just log something into the console with console write line, and then say store this new user in the database. And we will do that later, of course. Great, and now the edit form with all the user register model properties. This time, instead of the validation summary, we will use the validation message below the corresponding form control. Maybe it's more convenient for the user, maybe it's not. I leave this up to you. Okay. So we start with an edit form again, and the model now is the user, and on valid submit we call handle registration. Again, we can add the data annotations validator, and then we start with the email. So we add a div with the class form group. We add a label, which is for the email, and give it the email text. And here we add the input text with the ID email and bind the value user email, and can add the class form control. And then, as I said, we can use a validation message. And again, this looks a bit strange maybe, but what we have to do is we add a function here with a lambda expression user email. So that's how we get the specific validation message for the user email. Okay, and now we have to copy this and paste it a few times. We have another div. This time this is for the username. The ID is also username. Of course, the property, and the same here. Okay, now the password. We have a label for the password text. ID of the input text is also password. We bind the correct property and also add the type password this time. And here the property for the validation message. Okay, and now the similar thing for confirm password. So the label is for confirm password, the text is the same. Also the ID the value. Again, we add the type password. And of course, the correct property for the validation message. Okay, next is the bio. Bio label is also bio. Now this thing will be a text area. The value, of course. And since we had no attributes, we have no validation, so we don't need the validation message for the bio of the user. Then the bananas. So this is the label for the bananas. ID is bananas, and this is an input number component. We bind the value bananas, and the same for the validation message. And then the starting ID, this is getting a bit more interesting. So let's give this thing the ID start unit. Start unit. Text is start unit. And now this thing is an input select. And we don't close it here. We close it here. We don't need the validation, but we bind to the start unit ID. And now here we add a foreach. And we want to use the units of the unit service. So we have to inject the unit service on top first. But let's just complete this component here, or this control. We add an option with the value unit ID to string, because again we need a string here, and this will be displayed with the title. And real quick on top we inject the Blazor Battles client services, unit service, and now down here this should work now. Yes, okay. So we've got our select, a little bit more complicated, just because we want to use the for each with the units of the unit service. And then we can go to the next property, which would be the date of birth. And again, we fix the label, date of birth, change the ID, set the correct property, and we have no validation message for that, but we have to change the component. As you can see here, we have to choose input date. Okay, and then the last one, which is the checkbox for confirmed. And now here we use the class form check, and this is the label and the ID confirmed. The label text is confirmed. We've got the validation message is confirmed. The property is confirmed. again, here we need another class, which would be check input. Of course, the other component, input checkbox. And I think it looks better when we switch the position of the checkbox and the label. Okay, now this was a lot and I hope there is no typo anywhere. So we save this and then we have a look and test all the validations. One more thing we have to do, since we've got a new page here, we stop and restart the application manually. And now we go back to Chrome, reload the page, and then go to the register page. And there is our big form. Now this is already quite nice. And I see that I forgot one thing, the most important one, which is the button. So let's add this one real quick. Type submit. The class is button primary, and just call it register. Save this and then reload the application. Okay, now we've got a button. And what happens if we click the button already? We see that two fields are required, the email and the password field. And we also see that the message, the validation message is now below these fields. Okay, now what happens if we enter a username which is too big? Like, this is my big username. Register, your username is too long. 16 characters max, perfect. Now, what about a password that is too small? The field password must be a string with a minimum length of 6 and maximum of 100. Perfect. So we do something like that and add a wrong password here for the confirmed password. The passwords do not match. Okay, now what about the bananas? Great. And now we uncheck this, only confirmed users can play. Okay, actually, I think that this works. So let's fix this by adding a valid email, a username, a password. Then we add only 1,000 bananas. You can see that this is a number field here. We have the different starting units, we have the date of birth, and we want to be confirmed. We register, and we want to store this new user in the database. Whew, okay, perfect. Now this works. And it was a lot. And there's one tiny thing I want to add next, and then we are done with forms for now. There may be times in a web application where you want to navigate a user to a certain page. For instance, after the registration process, you may want to navigate the user to the login page so he or she can start with the game. Now with Blazor, you can use the Navigation Manager for that. So in here in the register component, we first inject the Navigation Manager. So inject Navigation Manager, and we call the manager also Navigation Manager. And now in the handle registration method, we remove the logging here and use the Navigation Manager with the navigate to method to go to the login page. So Navigation Manager, navigate to, and then login. let's have a look. We reload the page. We add an email address. We add a password. And we are redirected to the login page. Perfect, this already works. One more little thing. As you can see, these two look a bit different. So let's fix the login form real quick. So back to Visual Studio, and here in the register component, we just copy the password and the username and put it here. The only thing we don't need are the validation messages here, because here we use the summary, but in essence this should already be it. So we save the login and reload it. All right, and now this form looks better, I'd say. Yeah, great. All right, so we're done with forms for now, and now it's time for authentication. Now, if you made it this far, you're definitely ready for the complete Blazor WebAssembly full stack bootcamp. You have what it takes to build a full stack web application with Blazor WebAssembly, Web API, and Entity Framework completely by yourself from start to finish. In the next lectures of this course, you will add authentication to the client with the help of the authentication state provider and the authorized view. Then in the following sections, we will dive deep with a Web API, Entity Framework, and SQLite. So you will build the web service that'll be called by the Blazor WebAssembly client, and you learn how to store the data in a database. Additionally, we will implement token authentication with JSON Web Tokens, and after that we will enable users to store their units on the server, fight battles against other users, climb the leaderboard to become the best warrior, and watch the history of their battles. You see, there is still a lot to learn with Blazor WebAssembly. As a thank you and reward for completing this part of the course, I want to give you a pretty sweet discount. Make sure to use the link in the video description below. I'm looking forward to seeing you again in the complete course.